All right. In this video, I'm going to show you different examples of solving equations that have some special things about them. For this first one, this is going to involve something called distribution. And there's actually a couple ways that you can solve this. I'm going to choose to distribute, which means you take that number in front of the parentheses, 2, and you multiply it into the terms that are inside the parentheses. So what I mean by that is I am doing 2 times 3x. I'm also going to do 2 times 4. And I'm going to choose to view this as a minus. So I'm going to put a minus between them. So that is distribution. So just multiplying. So this kind of simplifies out to be 6x minus 8. I'm going to drop that plus 6 down, drop the equals, drop the 22. Now, of course, there's always more than one way, one method to solve these equations. You could have chosen to taken that 2 and divided it at some point during this solving. That's perfectly fine. I am choosing to distribute first. Okay, so that was my first step. My second step is to combine like terms. Okay, and that's kind of a broad statement. I want to focus on the constants when I'm combining like terms. And constants is just a fancy math way of saying the numbers that don't have a variable. So if I look on the left side, I see right here, -8 plus 6, which of course is -2. So I have 6x minus 2 equals 22. All right, 2 more steps. You'll notice that I drew this line where the equal sign is because I always like to kind of separate the left side and the right side. So if I choose to add something, subtract something, multiply, divide, if I choose to do something to one side of the equation, that line just reminds me to keep it balanced, do it as well on the left side. So what I mean by that, in this step, I'm still combining like terms, right? And I'm still kind of focusing on constants. I see this -2 on the left and this positive 22 on the right. Those are constants. Those are like terms. I want them to be together. I want my x to be isolated. So 6x, I want it to be all alone. So what I'm going to add to the left side is add 2. And like I said, we're going to have to keep the equation balanced. So whatever I do to the left, I got to do to the right. So my next step is I am adding 2 to both sides. And the reason why I'm adding 2 to both sides is because if I have -2 plus 2, those are actually going to equal 0. So with those zeroing out, you can see on the left I am now left with a 6x. And on the right, I'm adding 2 to my like term, so 22 plus 2 gives me 24. Now, the goal of this equation is I want it to be x equals something, but unfortunately right now I have 6 x's, right? I only want 1 x. So the last step is to divide 6 to both sides. So I just gotta divide 6, and 24 divided by 6 is 4. Now, we want to get to a place where we are able to check our work, right? That way we can feel confident about our answer. So the original equation, so the thing we started with, I'm just going to take a moment to rewrite it. And where I see the x, so x was usually right here next to the 3, I'm just going to put a big parentheses. And guess what's going to go into our x? Our answer. So we're going to just do a little substitution. And what I got to do is just simplify the left side. And if it ends up equaling 22, then I know that I'm correct. So let's remember our order of operations, also known as PEMDAS. I will start with 3 times 4, which is 12. I'm just going to write the left side, save the equals 22 to the very end. So I did 12. I see in my parentheses, because that's where I'm starting, is with the P for parentheses. In my parentheses, I am seeing 12 minus 4, which is 8. Okay, so we finished the parentheses off. We still have a parentheses here, but there's nothing really inside for us to do. We don't have any exponents, so we can skip that. Next, it's telling me to do either multiplication or division. And you kind of start on the left side and see which multiplication or division happens next. I see 2 times 8, which is 16. And then the last thing, because I did my multiplication, the last thing is to do the addition. And 6 plus 6 is 22. We see I got my 22, so it checks out. So I know my answer, x equals 4, is correct. So I'm satisfied. All right, let's move on to the next type of special question. I'm going to do my line. It tells me to solve for x. I have 5x squared plus 43. And then I have this situation over here that's unusual. I'm seeing some parentheses, right? Inside this one is x minus 1. Inside this one is 5x plus 6. This, when I see two parentheses right next to each other, this is telling me to multiply. I need to multiply x minus 1 and multiply 5x plus 6, right? I got to multiply these two things together. Now the method I teach my students is something called the box method. So I'm going to start with just drawing a box, more specifically a rectangle. I'm seeing x minus 1. I'm going to put that on the length side, and I'm going to draw a line to separate these two things. X for the top, -1 for the bottom. The second parenthesis is going to go on the width, 5x plus 6. Draw a line, just separating them. And now I'm going to treat this like a multiplication table. So for this first box, I see x matches with the length, 5x is the width. So when I multiply them together, I have 5x squared. Because remember, x times x is an x squared. There's really a 1 in front of the x, so 5 times 1 is just a 5. Let's do for the next box. I see the width is 6, the height is x, 6 times x is 6x. Next one, 5x times -1 will give me -5x. And finally, 6 times -1 is -6. Okay. So we have to take all the stuff in these rectangles, in these boxes, and we want to write our new expression. And remembering our like terms, so remember to add up your like terms. So we got 5x squared in our first box. In the next two boxes, I'm noticing a 6x and a -5x. So instead of writing 6x minus 5x, I'm actually just going to simplify those. And I notice 6x minus 5x leaves me with a 1x, so I just write it as x. And then -6 or -6. Okay? So we just multiplied these two expressions, and now we have this new expression called a quadratic equation, or even a trinomial. There's a couple ways you could call it. All right, so now we have a much more manageable equation to solve. I want to get back into combining some like terms. I always like to start with the highest degree. So x squared and x squared, I'm kind of focusing my energy on that. And something special, if I subtract 5x squared to both sides, you'll see something kind of special happen. So minus 5x squared minus 5x squared. You can see that these actually cancel each other out. They zero out. So I will be left with 43 equals x minus 6. Which, lucky for us, just leaves us with one last answer, or one last step. I want x to be all by itself. I see 43 and -6, they are constants. They are like terms, so they want to be together. So if I add 6 to both sides, that will actually end this process for us. So I will have x equals 49. And because we want to be confident with our answer, I am just going to check my work. So I'm rewriting the answer, or I'm rewriting the equation, but I'm leaving parentheses where the x's are. This is going to get a little tricky because I already have parentheses. So maybe here, instead of having like an x minus 1, I'll just write in, we just have to be careful with our organization here. Don't get too intimidated by all these parentheses. All right, so we said our answer is 49. So everywhere where those x's were, I'm putting a 49. Okay, and this is going to be kind of an intense little checking method, but let's get into it. So 49 squared, let me go ahead and turn to my calculator because that is going to be a big number. I see I've got 5 times 49 squared is 2,401. Okay. Here's a little bit nicer. 49 minus 1 is 48. 5 times 49, let me get my calculator, is 245, and then plus 6. Okay. How about we solve the left side, because we got some stuff simplified. Let's solve the left side, and then we can solve the right. So first things first, we got to multiply 5 times 2,401, which is 12,005. And then we just add 43 to it. Okay, so I have 12,048. Hopefully we see that the right side gets us the same answer, gets us this 12,048. So first thing is this 48 times, and let's add that together. 245 plus 6 will give us 251. And remember, these two parentheses are being multiplied. So 48 times 251 is giving us 12,048. Checks out. So that, even though these are big numbers, let's not be too intimidated by them. This is all math that we are able to do. We just have to keep it organized, right? So even though this felt like a lot of steps, we got to our answer, 49, and we remember when we see parentheses like this, with 2 terms, a binomial, times a binomial, let's create the box method. Let's create this generic rectangle just to keep our work nice and organized. Hopefully this was a helpful video for you, and good luck with all of your math work.